हाँ किया. Hello, hello. Guys, is it audible now? Hello. हेलो. अभी ऑडिबल है गाइस? ओके चलो ग्रेट. आज मैं लेक्चर लेने वाला हूँ. हेलो. सो फर्स्ट ऑफ ऑल लेट मी इंट्रोड्यूस माई सेल्फ गाइस. हेलो हेलो एवरीवन. माई सेल्फ ज्वाला चौरसिया. I'm a third year student at Thakur College of Engineering Technology, BTech AIML. Uh, Previously, I have did internship at Upgrade as a software development engineer, and currently from last 1 year I am working with CodeChef as a video editorialist and problem setter. I am ICPC 2022 regionalist, and in upcoming month, that is on June, I will be joining JP Morgan and Chase London United Kingdom branch as an international offer. And this is something I have to tell about myself. And I've also took DSA boot camps, competent programming lectures on CodeChef. Okay, around more than 200 300 students as the paid camp. So today we will be learning as per the given task, as per the given thing. Okay, so what are you doing in ML? Like any specific? Okay, he will share. Abhinav, Abhinav will share all the resources. No need to worry. First of all, let's focus on today's lecture. Okay, जो भी है टुडे लेक्चर पे, आज के लेक्चर पे फोकस करते हैं. ठीक है. So today basically we will be working with basics of time complexity. Most of the part will be on theory, and tomorrow what we will be learning will most of the part on coding part and most concepts part. But today's lecture is most of the part on theory. So we will learn the insights of time complexity, space complexity, और टू रोहित व्यवहार है. सो रोहित, आज का लेक्चर मैं ले रहा हूँ, है ना. अभी से 4 दिन लेक्चर मेरे होंगे, है ना. सो ऐसे शेड्यूल थे, आप देख सकते हो शेड्यूल में जाके वहाँ पे वेबसाइट पे. सो इट वाज द शेड्यूल. ओके, सो नो नीड टू टेक टेंशन. अच्छे से पढ़ेंगे ना. सो लेट्स स्टार्ट विद टुडेज लेक्चर. सो इज एवरीवन देयर? Okay, so today we'll be learning insights of time complexity, some sort of basics of space complexity, and some mathematical things such as number theory, uh, some concepts of number theory. We'll be learning about some concepts of number theory. Okay, so no need to take tension. We're working very finely over there. Okay. So I think my screen is being shared perfectly over to you. Okay. So and after completing the session, I have also made few good notes of time complexity and space complexity. I will be sharing, though I will be teaching from there too. I will be sharing you the notes too in the group. Okay. So no need to take tension. So I think the screen is visible. Okay. So okay. So start with. So, guys, is my board visible to you? Whiteboard. Say yes or no. Okay. So let's start it. Sure. So first of all, let's start with learning what we are having it. So today we will be learning of time complexity, and space complexity. Okay, and some basic concepts of of the few concepts of mathematics or number theory, we can say math slash or number theory, which are very useful during DSA and when you do competitive programming. Okay, take. So when I say let's start with time complexity part, it's one of the very crucial part when you learn data structures and algorithm. Okay, so in most of the interview, they will ask, tell me what is the time complexity of this code or whatever this code block is working on. What is the time complexity and what are the various things, space complexity of it. Okay, so this would be a very much important question, or it is a must question which is asked during an interview period. Okay, or during the problem solving time while you're working in solving problems in competitive programming, it is also a very useful thing. Okay, over there. So okay, so let's start it over here. So time complexity. So when I say time complexity, what is the time complexity? Okay, so when I say what is the time complexity, so when I put a code on my compiler, then you will be getting that this code has been solved in some of the seconds, let's say 2 seconds, 3 seconds, 4 seconds. Okay, just don't get confused. This is not the time complexity, it's the time taken. Okay, this is the time taken. This is not the time complexity, this is the time taken. But when I say a time complexity, let's say I'm working with some of the code over here. Okay, okay, there is some code over here. Okay, so when I say, so let's analyze the time complexity. Okay, so when I say a time complexity, what it is, so time complexity is not the time taken. Okay, so time complexity is not time taken basically. One second. Okay, so don't get confused with this. Okay, so it's not the time complexity. So when I write a simple definition of it, time complexity, it is the rate, you know, it is the rate at which time taken increases, okay, with respect to input. Okay, or the input size. So when I say what it is, let's make few of the graph and understand how does it work. So time complexity, it is a rate at which the time taken increases with respect to the input size. Okay, so when I say time taken, a time taken can be differ when you are using some different sort of machines. Let's say I am using some a machine which is very old. Let's say it was made in 2010 or 2011. Okay, and right now I'm using a latest model of my computer. So the time taken may differ according to your CPU. Okay, but the time complexity won't differ. So that's the hint over here. Okay, so let's work. Okay, so let's say I am having some of the earlier books, or I can say some earlier computer. Let's say I'm some Pentium PC. Okay, so let me make a graph over here and make you understand how does it work. Okay, okay, and let's say this is a new i7. Okay, let's say it's a new i7. I will be explaining time complexity with respect to this. So let me write the time over here, and over here the input size, time, and the input size. Okay, so let's say I'm incrementing the time by like this 1, 2, 3, 4, 5, 6, and the input size, let's say by 10, 20, 30, 40. Okay. 1, 2, 3, 4, 5. Okay. Okay. So as you can see, as the time, as the size of input increases, my time also increasing. Okay. So if I am making over here this graph, okay, and this is some angle theta, let me write over here 10, 20, 30, 40. Okay, so as you can see over here that as the time, as the input of my, as the size of my input increases, the time taken is also increasing. So as you can say, this is the rate, right? So this is my time complexity. It is the rate at which the time taken increases with respect to the input size. Okay, it is the rate at which the time taken increases with respect to the input size. So guys, is these things clear to you? Okay, let me check the charts. Bottom of them is important, but most of them, as I can say, is time complexity is very much important. Let's move forward and make it and take it more in deeply. Okay, so as we got some sort of definition of what is the time complexity, okay, right now, but how we denote it, or how we note, what are the notations of time complexity, we will learn in that detail. So basically I am not teaching you some sort of a theory lecture, so I won't be going for all the theory part, but what are the concepts which are basically mostly used during the interview period or during your problem solving, I will be teaching you that only. Won't be going much in depth of the theory wala part. Okay, I think that's all are available in the textbooks, and also we learn during our uh, engineering. Okay, so let's move forward. So when I say time complexity, let me denote it with TC. So I denote it with big O notation. Okay, big O notation. So basically, what is big O notation? This is the big O notation. And what we write in this blank space is the time taken. What we write in this blank space is the time taken. So this is the general definition of time, or the general notation of time complexity. Okay. So let me write a code block, and will make you understand. For I equal to 1, I less than equal to 5, I plus plus. Okay, say out Jwala. Okay, so guys, anyone can over here can say that how much time it will be taking to print, how much time this for loop will execute. Okay, so can I say it 5 times? First, it will increment. Okay, then it check, then it prints, then it increment, checks, then it print. So it go will till 5 times, but there are 3 steps. Then 5 times, but there are 3 steps, right? So can I denote it with like this: O of kn. K is the number of steps, and n is the time or the complexity. I can say that. Okay, it is working this for loop. So, but this k is a constant, so we can actually ignore it. Okay, so it won't be a big number in front of n. So basically, we write it as O of n times. So it will be, this loop will run n times. So O of n is my time complexity over here. So this is something I can say you. Okay. So what are the 3 rules of writing a time complexity or getting a time complexity? The first rule is time complexity to be computed in terms of worst case scenario. Okay. Second, second point is we have to avoid the constants, and the third part is avoid lower values. So when I say I have to get a time complexity, we talk in the terms of getting the worst case scenario. Okay, we always talk in the terms of a worst case scenario. If I will explain you that why we always talk in a worst case scenario, let's say I will get you an example such that, let's say you have made some product. Okay, you have made some product. Okay, so uh, for one person, okay, let's say you have made a product, let's say some product, some of the website or something, anything you have made for one person, uh, and same product, some other product for 1 million person. So what you will be wanting, that product should work only for one person or 1 million person, 1 million people, precisely. Okay, so that's the case, that's the worst, I mean that would the large. Okay, so we see it for the large scale. So time complexity help in working up in a large scale scenario. That's why we actually write the time complexity for the worst case scenario. Okay, so that's a simple explanation why we actually do this. So just remember these three important points, that time complexity to be computed in terms of worst case scenarios, we have to avoid the constants and avoid lower values. Okay, let's move forward. Okay, so okay, so what are the various scenarios we can see during the time complexity? Okay, so when I say it, best case, average case, worst case. Okay, best case, average case, and worst case. Let me write a block of code for you and make you understand. Let's say if marks is less than 25, I will see out grade B. Else, if marks is less than 45, I will print out grade C. Else, if marks is less than 65, I will print out grade B. Else, see out grade A. Okay, let's check what will the best case, average, and worst. Okay, so when I will be getting my worst, best case scenario, let's say in input I have got 10. So what would be the number of steps? So simply what it will do, it will check the condition and simply print. So O of 2. So this will be my best. So let's say if I have got input as 70. So what it will do, it will check this condition. Okay, it will move forward, then it will check this condition, it won't satisfy, it will move forward, then it will check this condition, it will move forward. Till now 3 steps. Okay, and after on it will simply print this. That would be my last step. So it all took over 4, that was 4 steps, right, or the 4 time complexity. So it's a constant, right? So for marks 70. So I think this is very much clear to all of you guys. One second. move forward. So when we saw the three rules, so first rule we saw that, and the second rule was that we have to avoid the constants. Okay, so why we actually do that? Let's see it over here. Okay. When I say we have to avoid a constant, okay, let's say I have got some time complexity like this, over 4n cube plus 3n square plus 8. Okay, and let's say my n is equal to 10 to the power 5. This is my input size. Okay, so how this equation will become, it will become over 4, 5 into 3, it will come as 10 to the power 15 plus 3 into n square, that is 5, and not n square, it will be 5 into 2, that means it will give me uh, 10 to the power 10, and it will be plus 8. So what do you think, this constant 8 will have any significance in front of 10 to the power 15 and 10 to the power 10? So 10 to the power 15 is a very huge number, right? 10 to the power 15 is a very huge number, am I right? So what do you think, is this 8 is gonna have any significance in front of these 10 to the power 15 and 10 to the power 10? No, right? So well, this have any significance? No, right? So we can avoid these constants. And third was avoid lower values. So let's say over here I was not having 10 to the power 10, I was having something 10 to the power 1 or 10 to the power 2. So what do you think, these lower values is gonna have any significance in 10 to the power 15? Is 10 to the power 2 or 10 to the power 3 is having any significance in front of 10 to the power 15? No, right? So we can avoid it. So that's a simple case, if we get a simple understanding. Okay, so let's go for a few notations which we are having in time complexity. Generally these things come on theory questions only. So when I say it comes of big O, which is noticed by this, then theta, then omega. Okay, so when I say big O is being notated in upper bound complexity or the worst case scenarios, or I can say it on upper bound time complexity. Omega is being denoted in lower bound complexity, that is the best complexity or the best case. And theta is denoted in average complexity. So it's a simple understanding of how these work. It will be, it is noted on the worst case, it is noted on the best case, and this is the notation for the average time taken complexity. Okay. Let's take a few questions and understand how does it work. Okay. Okay. So okay, so let's say I'm writing a few block of code for integer I is equals to 0, semicolon I less than n, semicolon I plus plus. Okay, for integer j is equals to 0, semicolon j less than n, semicolon j plus plus. This is semicolon, right? Just don't get confused. Okay, there will be some block of code over here. Let's say it will take some constant time. Okay, let's say simply I'm printing something over here, block of code. Okay, so now let's take out the time complexity for this code, what it will be. Okay, so let's just check it, how does it working. Okay, so when my I is equal to 0, my j is iterating from 0 1 2 3 till n. When my I is equal to 1, my j is iterating from 0 1 2 3 till n, right? When my I is equal to 2, my j will iterate from 0 1 2 comma 3 till n. And when my I is equal to n minus 1, my j will iterate till n. So as you can see over here that it is iterating from n into n times, right? This n times into n times. So basically, when I say that n into n times, so over here I can say that my time complexity will be O of n square. Okay. So guys, is this clear? Okay, so guys, if you are having any doubt, you can ask. Okay, let me move forward. Let's solve few more questions and understand how does it works more precisely. Okay. Let's take one more question. Let's say uh, for I is equal to 0, semicolon I less than n. T is equal to T plus plus. Okay. Some code will be here and it will. Let's just focus precisely over here. How does this code work? And I will make you understand what will be the time complexity for this code. Okay. Okay. So when I say that if over here I is equal to 0, my j will also be equal to 0. Am I right? When my I is equal to 0, my j will be equal to 0 because it will iterate till I. If I is 0, then it will iterate till I, that is equal to 0. Am I right? Okay. So when my I is equal to 1, my j will iterate from 0 comma 1, 0 till 0 comma till 1. Okay. When I say my I is equal to 2, it will iterate from j is equal to 0 comma 1 comma 2. When I say my I is equal to n minus 1, it will iterate from j is equals to 0 comma 1 comma 2 till n minus 1. Am I right? So guys, can you see over here that how many operations? I am simply adding plus one operation in each step. Okay, so when I say operation, how many operation? It is simply going 1 plus 2 plus 3 plus 4 till plus n. Every time my one operation is being increasing over here for this block of code. Just don't get confused, it's different over here. It's j is less than equal to I, right? So it's iterating till I. Okay, so can you observe that what is this? If you have learned sequence and series, this is the sum of n numbers. Okay, so this is simple sum of n numbers, and how we make a formula or equation for sum of n numbers, that is n into n plus 1 by 2, right? So can I write n into n plus 1 by 2 like this? N square by 2 plus n by 2. So can I write it as only n square by 2, as this is a very lower value in front of n square? So can I avoid it? Okay. Also, can I avoid the fraction part, that is 1 by 2 of n square, because it's also a lower value or a constant, you can say? So can I write the time complexity of O of n square? So when I interviewer asks, first of all, try to give this solution, and you can also give this too, but it will more uh, good if you give this right. Is these things clear to all of you guys? We will take one more for log and time complexity. How does it work? Okay, 734. Chalo, clear है ना? Work fine. Yes, Sakshi of n square. Okay, this is n of n square time complexity. Okay, okay. Let's move forward. Let's take one more question. Let's say I'm taking some input integer of n. Okay, and I'm running a while loop while n greater than 0, n equal to n by 2, and over here let's say I'm making a counter variable as equal to 0. Okay, so first of all, let's understand what this code does. I'm running simply a while loop. Okay, I'm incrementing. Okay, also I'm incrementing my counter over here. I am running a while loop. Okay, and I'm checking until my that integer n becomes 0, such that how I am doing, I am dividing that n by 2 until it becomes 0. Are you getting? I am dividing that integer by 2 until that integer becomes 0. So let's check what will be the time complexity of this. It's not a linear iteration. Every time it's becoming half, right? So when I say that what this code is doing, let's say I have an input 10. In first step, it will divide it by 5. The second, in the first step, it will divide it by 2, then it become 5. Then it will divide to 2, then it become 1, then it become 0. So guys, how many steps it took? As you can see over here, 1, 2, 3, 4, right? To become 0. Let's say I have got 8, then it will go for 4, then it will go for 2, then it will go for 1, and then 0. So the code says that uh, I mean I'm counting at how many time it is taking that n to become 0 by dividing that n by 2, or I'm counting the times in this counter variable. Okay, just don't get confused. Okay, so when I say that I have to get the time complexity for this code, then how I will find it? I will find it way when I say that I am dividing n by 2, let's say a times. Okay, I am dividing n by 2, let's say a times. So can I write it is like this? 2 to the power a is equal to n. That means I am dividing n by 2 a times. Can I write it like this or not, guys? Someone over here can say me. Did you got this? What I wrote over here? Hello. Did everyone got that? What I said? 2 to the power a equal to n. Hello. Can anyone comment in the comment section? Okay, work fine. Okay, only Durvesh. Okay, Jyoti didn't got. Okay. Anyone else? Okay. So Jyoti, I'm saying that first of all, what this code is doing, just see it precisely. And I took input for n, then I made a variable says counter, and over here I am simply checking. I am simply counting the number of times it took to make my n to 0 by dividing by 2. Okay, so can I write as the 2 to the power 8 times? I mean, I have to divide n by 2 8 times. Can I write it like this? I am dividing 2. I am dividing n by 2 8 times, right? So can I write it like this? 2 to the power equal to n. So when I'm writing it like this, so let's say I am taking a log on both the side. So let's say I'm taking a log on both the side. So it will become 2 to the power a, which is equals to log of 2 to the power n. So if I will solve the logarithmic function, we have been learning these things in 11th standard itself. So this a will come over here. So it will become a of log to the power 2. It will become log of 2 to the base n. So this will become 1. So a into 1 will become a, and this will be my time complexity. So it's one of the best time complexity after constant, of course, of1 after constant. But in most of the DSA problems or most of the competitive programming problems, the interviewer or your online judge will ask you to solve the problem in this time complexity. Okay, it's the most one of the most efficient time complexity, that is log n time complexity, guys. So guys, did you all got that how I took the time, got the time complexity log n? Say yes or no. Okay, great. Uh, so let's move forward now. So we have learned almost the most important things of time complexity, whatever it will be asked to during an interview period or problem solving or in competitive programming. Let's learn about space complexity. Okay. So what is fixed complexity? When I say it's a memory space to web program. So how we note it? So basically what it is, so it also denoted by a big O notation. Okay. So what it is actually the auxiliary space plus input space. Okay. So what is auxiliary space? Auxiliary space is the space that you take to is the space that taken to solve the to solve the problem. It is a space taken to solve the problem. And what is the input space? Space to take to store the input. Space took to store the input. So basically, is the sum up of space complexity is the sum of both of these. Okay. So when I say I have two input A and B, and so C is equal to A plus B. So this C is the auxiliary space because it's solving something, and this A and this B is my input space. So over here I took how many? 3. So my time complexity will be over 3. Okay. So is these things clear to all of you guys? So if someone asks that, let's say you have an integer array of n length. So what will be your time complexity? It will be O of n because you took n space, right? The memory space will be n. So it will be your space complexity. Okay. So is these things clear to all of you guys? Say yes or no in the chat box. चलो बढ़िया. Great. So so over here we are ending with time complexity and space complexity. Okay. So as I said that we are going to be getting on each and theory wala part of these things. So but whatever you will be needing is the most of that I have taught you. Okay. So now we'll be going on mathematics on number theory. Some of the very important concepts of number theory. सब तो नहीं कर पाएंगे but the most important part we will be doing now next 15 to 20 minutes. Okay. So let's start with it. Work fine, guys. Well, okay. So okay. Let's learn few of the very important concepts of number theory. Okay. Okay. So let's learn about binary exponential. Okay. Uh, bit manipulation. I think this will be more than enough for today. You will be knowing what is GCD and LCM, right? How does it work? I won't be writing the code for this or something. I will just explain you what it is. I think we have learned these things in our sixth standard. Okay. तो इस पे ज़्यादा नहीं जाएंगे बट जो यहाँ पे सीखना है उस पे जाएंगे ना. So what is a binary exponential when I say that? So why we actually use? So let's say in a question you have given and in the question they have asked to calculate uh, let's say something 3 to the power 25. Okay. So don't you get that this is a very huge number? So what are the various functions which we are having to calculate this? We are having some sort of power function to calculate as of in C++ I know power function. Maybe in Python there will be something. 3 to the comma 25. Okay. So what is that? This power is in inbuilt function of this power is made in double. Okay, because we know that double is the largest store. Okay, that means it's the biggest data type or the storage of it. But do you know that double after some point of time it won't give you an accurate answer. Okay, it won't give you an accurate answer. It never. So so this power function is made in that you will get an answer but your answer won't be an accurate because it's in double. Okay. So okay. So what is something else we can do to solve this? Let's say you have got something sort of uh, in input to let's say 2 to the power 16. Okay. So if you don't know, then you will be using these functions, that is power function, that is 3 comma 25. Okay. Okay. So what's next? So what extra you can do over here, or what this binary exponential function teaches you? Okay. Is everyone with me over here? Yes, Dhruvesh. After some point of time, that means if you have got some bigger input, your answer you won't be getting an accurate answer. You will be getting some sort of uh, precision errors. That means let's say your output would be 1000, so you would be getting 999.99. Okay, so that's why that would be the thing, because in inbuilt it is made in double. And let you can try for printing 2 to the power 24. Try to print that or something that some bigger number, you won't be getting an accurate. Okay. सेशन विथ यू ऑन AIML देखते हैं, है ना. सीपी करते हैं, सीपी पे ले सकते हैं आगे के ना. पहले अब आज का सेशन कंप्लीट करते हैं, थोड़ा सा बाकी है. चलो. So how can we calculate? Okay. So just focus over here precisely how we can write it. It's a very I mean it's a high level concept in mathematics or number theory, but it seems to be very hard, but it's very easy concept. But just I'm teaching to you. Okay, just don't get confused. Okay. It's a very easy concept. Basically, we use in competitive programming, solving good number of high level of questions, say 1600, 1700 code forces. Okay, just focus it. So when I say I have to calculate to the power 16, so So can I write 2 to the power 16 like this? If I am going in a traditional method of brute force of using for loops, so it will iterate 16 times, right? So I have to calculate 2 into 2 into 2 into 2 till 16 times. If I am going in a for loop, simple, just multiply it, right, every time. Okay, so it's a very big number. Okay, so it's a traditional method. So can we do something more uh, precisely, so that my time complexity as well as my space is being reduced? Okay, how my time complexity will be reduced? The number of steps reduced, also my space also will reduced. So if my number of steps are reduced, both of them will be reduced. That means I have optimized my code. Just focus over here. Okay, so can I write 2 to the power 16 as 2 to the power 8 into 2 to the power 8? Can I write 2 to the power 8 as 2 to the power 4 into 2 to the power 4? Guys, focus here. Can I write 2 to the power 4 as 2 to the power 2 into 2 to the power 2? Can I write 2 to the power 2 as 2 to the power 1 into 2 to the power 1? So guys, just focus over here. First of all, I will calculate 2 to the power 2, then I will calculate 2 to the power 4, then I will calculate 2 to the power 8, then I will calculate to the power 8 into to the power 8. So everything I have just calculated it in 4 steps. Okay, so calculating this directly will be a big issue, but calculating this won't be an issue, right? So we can write a recursive as well as a iterative code. Okay, so I will show you how recursive pseudo code will work. Try to do the iterative on your own. Okay, so over here it was taking 16 steps. Over here it took how many? 4 steps. So that was the case. So let's say I have got an odd power. Okay, let's say I have got an odd power. Let's say it is something of 3 to the power 13. Okay, so can I write 3 to the power 13 as 3 into 3 to the power 12? Can I write 3 to the power 12 as 3 to the power 6 into 3 to the power 6? Can I write 3 to the power 6 as 3 to the power 3 into 3 to the power 3? Can I write 3 to the power 3 again as 3 into 3 to the power 2? Can I write 3 to the power 2 as 3 into 3? So I can more go beyond that. 3 to the 3 into 3 as 3 as 3 to the power 0 into 3 to the power 1. So it over here, when I was going for the traditional method, it was taking me around 13 steps. Now over here I took around 4 to 5 steps to solve it. Okay, so let's go on some more mathematical part, deep part. Okay, just it's easy, guys. Just don't get in a trauma or something that is very hard. So when I say you all would have learned these things in your 11th, 12th, JE means advanced, whatever. Okay, so when I say f of a comma b, where b is even, so basically we define a to the power b. Okay, that's my index and this is my power. Okay, or my base index. Okay, so when b is even, can I write it as f of a comma b by 2 into f of a comma b by 2, right? But when as of f of a comma b, when my b is odd, so I have to write it like this: a into f of a comma b by 2 into f of a comma b by 2. So as I will be dividing in integers, so it would be getting me the uh, base part. Okay, uh, a number which is before decimal c. Okay, okay, so this would be the simple formula for calculating my power function. So how I will be writing? Simple. So let's say I am passing in my function integer a comma integer b. First of all, I will be checking is my b an odd number. How I check? I will simply check by b and 1. If it is, I will simply use this formula. I'm writing the pseudo code. Okay, just don't get confused. F of a comma b by 2. It's a recursive. Okay, f of a comma b by 2, and else And what would be my base condition for this? When my b equal to 0. Okay, it will be my base condition. Else, if it is an even number, how I will be writing it for even number? F of a comma b by 2 into f of a comma b by 2. Okay, you can simply store these in a res integer, let's say in any of the variable, and you can simply write res into res. Okay, so this is something of when I say binary exponential. Now let's move forward on bit manipulation. We're learning few techniques very fast over here. So when I say bit manipulation, it's one of the very much important techniques while in competitive programming and data success in algorithms. It's widely used. Okay, these techniques are used widely to decrease your time complexity. Okay, so how does it works? Finally, okay, let's see. So first of all, you will be knowing how we represent a number in decimal number into a binary number. So let's say it's always noted in 2 to the power. Okay, a binary number, that is 2 to the power 0, to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, and it will go till here. It will go on. So what it is: 1, 2, 4, 8, 16, 32, 64, and it will go on 128. So you will be knowing that our memory card, what we are having in a phone, is also in these powers. Okay, it's not 33 GB or it's not 61 GB. Okay, it's always in these numbers, so you can relate it with that. Okay, so let's say I have got an integer 10, I have to convert it into a binary number. So how can I write into a binary number? So okay, so I will also set it. First, most important thing, when I say a number is set, it is denoted by 1, and when a number is unset, it is denoted by 0. Okay, okay, so let's say I have one input at 10, so I have to represent it into a binary number. How can I represent it? So can I represent it like this: 1010, this is 8, this 4 is 0, that means it's unset, this is 1, and this is 0. Okay, so 8 plus 2, that is 10, so that's my binary representation. Let's say I have to represent 7. Okay, so 7. Okay, so how I will denote 7? Can I denote 7 as 0 1 1 1, that is 4 plus 2 6 plus 1 7, 4 plus 2 plus 6 plus 1, that is 7. So okay, so one thing you will see that if my number is even, then its LSB is always 0. If it is an odd number, its LSB is always an 1. What is LSB and MSB? Okay, so LSB and MSB. LSB is known as the least significant digit, and MSB is known as the most significant digit. Okay. Hmm. So these are the basic things of that. Okay. So let's say if in a question they have said that, let's say you have got this 1010. They have asked you to count the number of set bits in this binary number. So how will you do? You have to simply count the number of set bits. So anyone in the chat box can answer me how I will doing this. Yes, Jyoti Sinha, you are right. Basically it's that only. In iteration part we can use DP. Okay, so let's focus over here. So can anyone answer me of that? How can I count the numbers of set bits? Hello, is anyone there? चलो आगे बढ़ते कोई बात नहीं. So I have to count the number of set bits. So all of you would be knowing what are these things: and or. Okay. So let me write you the table of that: A and B. Okay. For and, let's say 1 0 0 1 1 1 0 0. Okay. So for and to be true, both of them should be 1. or either it will become false. Okay, so 1 and 0 it will give me 0, 0 and 1 it will give me 1, 0, 1 and 1 it will give me 1, and 0 and 0 it will give me 0. Okay, so what I will do, let's say, or either I can say I'm not counting. What I will do, I will simply, what I have to do, let's say I have to make this set bit to an unset bit, or sorry, not this one, that's forward. Okay, let's say I have to make this unset bit to a set bit. For now it is unset, it is 0, I have to convert it to 1. How can I convert? I will simply and that number or that ith value with a number which has that ith value as a set bit. So if I am doing and with this 0 1 0 0, so oh okay, one, sorry, I'm sorry, okay, sorry. This is 0 1 and 0. So I'm not toggling over here, I'm just checking whether my bit is set or not set. Okay, for toggling we will be using XOR. I will teach you that after this. Okay, so let's say I have to check whether this bit is set or not. I know that, but the compiler doesn't know, right? So I have to check it. The question itself, if they have given to that, check this ith bit is set or not. So what I will do, I will simply do and with that ith bit of 1. If that bit is set, then it will become to 1. Okay, it will return me 1. If that bit is not set, then it will return me 0. That means if this was 1, then it will give me 1 and 1 as 1. If this was 0, then it will give me 0. So it will give me 0 0 0. So I can say that that bit is not a set bit, that means it's an unset bit. Okay, so this is a simple ways to calculate these things. Okay, let's move forward. Okay, so okay, this is a one of the very important concept that is known as XOR operator. So how does it work? That is A XOR B. It is the denotation of XOR. Okay, so 1 0 0 1 1 1 0 0. Okay, so it is 1 1 0 0. Mm-hmm. So when I did XOR with the same number, it will return me 0. In other case, it will return me that number itself. Okay, so it's very useful in toggling bits. How to toggle a bits? What is toggling? Toggling. Toggle means 0 to 1, 1 to 0. Okay. Let's say I have got 0 1 0 1 0. Okay. What I will do? Just see it. Okay. So basically, I will, let's say I want to toggle this bit. That means it is, first of all, it's a set bit. I have to convert it to 0. So what I will do? I will do XOR with 1. Uh, so it will become 0. Okay, so let's say I've got this number 0 1 0 1 0. So this is an unset bit, I have to make it to a set bit, so I will do XOR it with 1. So 1 XOR 0, it will give me 1. Okay, so it will 1 0 1 0. So this is something we use for XOR and toggling bit. There is a very famous question for, with the help of XOR we can solve. That's a very powerful concept, XOR. XOR is one of the most powerful concept when we come in computer programming and DSA. Okay, I will get in love with that. Okay, so let's say in a question you have said that you have got an array like this 2 comma 2 comma 3 comma 4 comma 4 comma 5 comma 6 comma 6 comma 6 comma 7. Okay, and comma 7. Okay, so let's say you have got an array like this, and you have to, and they have asked you that return me a number which is having an odd count, and the question says that all the numbers will be having an even count. Just focus. Return me a number which is having an odd count and all the numbers are having an even count. Only one number will be having an odd count. So what I will do, I will simply do XOR of all the numbers. So when I did XOR of this by 2, it will become 0. So 0 XOR 3 will return me nothing, right? It will be 3 itself. Okay, this will return 0, this will return 0, this will return 0, this will return 0. Only 3 is left, because as we saw that 0 XOR 3 or any, it will return what? 3 itself. All of them will become 0, right? Only this 3 will left, because any of the number, let's say 5 5, this will XOR this is 0. Okay, any of the time, that means an even time, right? So I will be XORing with them, it will return me 0. So 0 XOR 3 will 0, so it will return me a number that itself. So we can use these techniques very precisely while solving the question. Or other way of solving this question was making a map, which we'll be learning tomorrow, hashing techniques. Okay, we would have made a map and solved this. I mean, I have just counted the frequency, but it may take some more time. It will be taking a log n time complexity, but we over here we did in O of 1 complexity. That's in constant. Okay, it's the fastest way to solve it. So I think we are done with today's lecture. Okay, so everyone? Hello everyone. Is these things clear to everyone? सबको सही है? CP. Hello. सबको ही क्लियर है सेशंस के? किसी anyone having any doubt can ask me right now. Okay, we will be tomorrow we will be learning of what I mean, hashing techniques, and after on what are the various things are left, we will be doing very precisely. Okay, and I've also made the notes for today's lecture. Okay, I will be sharing with you in the group. Okay, so if you have any doubt, you can message me or also connect with me on my LinkedIn. Okay, you can search me on LinkedIn. Okay, so was the session good? I mean, everyone got it what I tried to explain. Okay, I mean, anyone want to be changes in tomorrow's lecture? I mean, I can work according to that, right? I mean, I don't just want to waste your time, right? If you are having anything explanatory you want to change for me, then you can just ask me. Okay, Swastik, you got it. Great. Anyone else? I mean, you too can say it precisely. No need to be sure. बोलो यार. ठीक. Okay, so let's meet tomorrow. So then, bye bye, guys. Thank you so much for being me over there, and please subscribe to our channel. Okay, so uh, okay, in this way, great, great. So, thank you, guys. Bye bye. Let's meet tomorrow.